Hello, this is Mr. Osmeyer, and this is a quick review of solving equations. These problems are from Chapter 3, and this will really help us out when we get to Chapter 6, which is solving inequalities. Hopefully we remember these problems fairly well. If we're looking at problem number 1, remember solving an equation, you basically want to get the variable by itself, move things away from your variable. So we have an x here and a 21 on the same side of the equal sign. We're going to want to get the 21 across. In order to get rid of an addition, you do a subtraction. Always undo things by doing the opposite of what's happening to your variable. If you subtract 21 on both sides, all you're going to have left is an x on the left side, and 11 minus 21 will give you a negative 10. Your solution to this equation is x equals negative 10. Remember, we always have the option of checking the solution by plugging in the answer into the original problem for x. So if we replace that x with a negative 10, in the original problem it said negative 10 plus 21 equals 11. And if you simplify it here, of course, it'd be a true statement. 11 equals 11. That's what you want to happen when you are checking the solution. You want both sides of your equation to balance. Number 2, very similar problem, except before you start moving things from side to side, occasionally in solving, we're going to need to simplify first. You know what 12 minus 18 is, so you might as well simplify that to make the problem easier. That's just combining like terms. 12 minus 18 is negative 6. This equation could be written as negative 6 equals x plus 3. Once you've done any simplifying possible, then just like problem number 1, undo what's happening to your variable. You want to get rid of an addition of 3 by subtracting it from both sides. Draw your line if you would like. On your left side, negative 6 minus 3 is negative 9. And your right side, you have an x, and your positive 3 and negative 3 undo each other, so they're gone. Your solution is, of course, negative 9 equals x. If you wanted to, same thing, you could plug a negative 9 up top. If you began to simplify from that, you would get negative 6 on both sides of your equation. Thus, negative 9 is a correct solution. Those problems were both from section 3.2 from our textbook in Algebra 1. If we wanted to, we could look at problems from 3.3, which is also just took one step to solve these types of equations. It wasn't always the same step. We did a subtraction on problem 1, subtraction on problem 2 after we had simplified. If you wanted to do problem 3, this is a 5 times x. You undo that multiplication by dividing both sides of your equation by 5. Divide by the coefficient. 5 divided by 5 is a 1. We never have to write a 1 in front of a variable. 30 divided by 5 is 6. You simplify that right side, and you have your solution. Once again, you can check solutions on any problem you want to. Plug a 6 up there. 5 times 6 is 30. That is the number we were looking for. Problem number 4, a little bit more complicated problem because it has a fraction involved. If you have a calculator, it's not a problem whatsoever. This is 3/4 x equals 7. Once again, looking for the number in there that makes this equation true. If you wanted to get rid of a multiplication of 3/4, you could, of course, divide both sides of your equation by 3/4. You can divide by 3/4, divide 7 by 3/4, and with a calculator, that's not a hard thing to do. If you don't have a calculator handy, you're probably going to want to think of this problem slightly different. To work without the calculator, we've discussed multiplying by the reciprocal of the coefficient to get rid of that fraction. So reciprocal of 3/4 is 4/3. You can choose to multiply both sides by 4/3. Multiply by 4/3. And if I was grading a problem like this, I would accept a lot of answers. Remember, you can think of 7 to 7 over 1. When you're multiplying fractions, just multiply the tops together. and multiply the two bottoms together. So 28 thirds would be my natural way of writing it. You typed it into a calculator, it might give you a mixed fraction or a decimal. The mixed fraction for this would be, see, 9 goes into 27, so that would be 9 and 1/3. Decimal would be 9.3 repeating. All those I would be just perfectly fine with. We could pick some more problems from later in the section that would take more than one step. If you're trying to solve 4x plus 5 equals 33, remember the goal is to get x by itself. Here, there's two things you have to get rid of. You have to get rid of a 4 as the coefficient, and you have to get rid of the addition of 5. Deciding what to do when there's more than one step available is a little tricky at first. We discussed this before, so hopefully most of you remember. The least important aspect of this according to PIMDOS would be the addition of 5, and you always want to undo the least important thing according to PIMDOS first. You undo addition and subtractions usually before you will get rid of multiplications or divisions. That's not always true. Depends on what PIMDOS says is the most important thing. That 4x hasn't gone anywhere, the 5's are now gone if I subtract the 5 across. If I simplify 33 minus 5, get 28. And now we just have one thing to get rid of, and that's that 4. Anytime it's attached, that's representing multiplication, so you must divide it away. Divide both sides by 4. And x is going to be 7 in this case. Check the solution if you ever need to. It never takes too long. 4 times 7 is 28. 28 plus 5 is 33. So it would check out. You don't even have to write it down necessarily. It's helpful to take that few seconds and make sure you didn't make an error somewhere in there. Your solution should check out. The least important thing according to PIMDAS is this subtraction, so I need to get rid of subtraction by adding 7 to both sides. 2/3 x is not going to move anywhere. 7's are gone. These two things cancel each other out. And 2/3 x equals 30. Once again, without the calculator handy, I am going to choose to multiply by the reciprocal of this. I'm going to multiply both sides of my equation by the same number, 3/2. The 2 and the 2 undo each other, the 3 and the 3 undo each other. That's why you choose to multiply by the reciprocal. And here you can think of this as 90 over 2. Or you can think of the division part of it first. 30 divided by 2 is 15. 15 times 3 is 45. Check your solution. It should check out. I don't believe we made any errors. 2/3 of 45, use calculator if you need to. Subtract 7, you better end up with 23. So there's two-step problems there, and if problems are more difficult, involving multiple steps, we got this here. I suggest we always simplify first. It's going to make your life easier. If there's more than one variable in the problem, get them together on the same side. You can choose to move them to the left side. You can choose to move them to the right side. It's really up to you, whatever's easier for you. If you've moved the variables, then move the constants in the other direction. Those are the numbers without any variable attached. Move them to the opposite side, and most problems finish with a division. Not all of these steps will occur in every single problem, but on certain problems you're going to have to do all 4 steps. So just think what's necessary. If you're looking at problem 7 here, we have a 12x plus 22. Nothing can be simplified on the left side of my equation. There are no like terms. There's no distributive property to take care of. Same thing on the right side. Nothing I can actually simplify. So problem 7 doesn't involve step 1 at all. You're ready to move your variables to one side. I usually end up moving the smaller number, 12x and 8x. I'm going to choose to move the 8x, but that's just my personal preference. These are not gone, but you do get a 4x when you simplify those. The 22 hasn't moved anywhere. And the 8x are gone on the right side, and we have a 2. Continue this, work ahead of me if you need to, if you're working on your own. we're going to now treat this just like our previous two problems. There's 2 steps left for me to do. I want to move the numbers in the opposite direction. I move my variables to the left, so I'm moving my numbers, constant values, to the right. 4x equals 2 minus 22 is a negative 20. I still need to get rid of my 4, which in this case is going to require me to divide both sides by 4. Running out of room, so I'll have to write my answer to the side. Divide both sides by 4. You should get an x by itself being equal to negative 20 divided by 4 is negative 5. It goes in there perfectly. Replace the negative 5 with both variables. You can do that without too much trouble. If you got a calculator handy, it's no problem at all. 12 times negative 5 is negative 60 plus 22. We hope negative 60 plus 22 gives us the same thing as 8 times 5 is negative 40 plus 2. Simplifying, you should get negative 38 on both sides. Your equation balanced means this is the correct solution. You have that option on every single equation you ever solve. Move my window over a little bit, display this problem, give myself some more room to work for problem number 8. So last problem I'm going to be doing here. Remember our steps. We're simplify, move the variables, move the constants, and then divide by a coefficient. If you need to, do all of them. Here I do need to simplify. This is a distributive property. 3 times both spots inside the parentheses. 3 times x is 3x. 3 times 2 is 6. Same thing on the right half of my equation. I need to take negative 2 times both spots. Negative 2 times 6, negative 12x. Negative 2 times, I like to think of this as a negative 5. That's going to be a positive 10. If you thought of that as a subtraction of 5, you would end up with saying minus a negative 10, and you go ahead and simplify that to an addition of 10 anyways. Okay, I'm going to get the line so we can see my whole equation, what I'm doing to each side individually. Got a 3x here, a negative 12x here. Can't combine them since they're on opposite sides of the equation, but I can easily move whichever one I choose so that they are together. I'm going to move this. It's a negative 12x. In order to get rid of it, I add 12x to both sides. Simplifying, you end up with 15x from that addition. 6 hasn't gone anywhere. This is gone, leaving me with just a 10 on the right half of the equation. 2 steps left. I need to move my constant values to the right side. I do that by getting rid of an addition of 6, subtracting 6 on both sides. 15x is still on the left side, and on the right side, 10 minus 6 gives me 4. The last step to get rid of that multiplication of 15, that's what this is when they're side by side, you divide by 15. 15 divided by 15 is 1. I never need to write down the 1 in front of a variable. And instead of typing 4 divided by 15 into a calculator, I might as well just leave it as 4/15. Fractions are absolutely okay, and they're usually easier than typing into a calculator and getting a decimal. If I wanted to, plug in 4/15 in each spot up top for x, I should be able to get my equation to balance out. That's all the ones we're going to review. Hopefully this will help us out when we get to Chapter 6, Solving Inequalities. Much of the same types of problems, except instead of an equal sign, we will have a greater than sign, or perhaps less than or equal to, greater than or equal to, those all mixed in.